Hello, today I'm going to talk to you about specific heat. And specific heat is the amount of heat that's required to change the temperature or to raise the temperature of 1 gram of a substance 1 degree Celsius. All right. So what that means is something with a high specific heat takes a lot of heat to change the temperature, whereas something with a low specific heat takes less heat to raise the temperature. So the example I have here is an iron frying pan. You know that most of the time we make pots and pans out of metals because they have very low specific heats. They heat up very quickly, which is often nice when you're cooking something. But it also means that they cool down very easily. Okay, so sometimes, depending on your cooking applications, you might choose something like an earthen pot, something made of clay or something like that. And that takes a lot longer to heat up. But it also then holds the heat longer, and so your dish inside would stay hot for longer after you remove it from the flame. So small specific heat, metals. Large specific heat would be other substances like clay or glass. Water also has a very high specific heat. All right, so all we're really going to do in this unit or in this lesson is make some calculations using specific heat. So the example I have here is a 225 gram sample of hot tea cools from 74 degrees Celsius to 22.4 degrees Celsius. How much heat is lost, assuming that the tea has the same specific heat as water, which is a pretty good assumption because tea is mostly water. And the specific heat of water is 4.184 joules per gram degree Celsius. Okay. Constants often have weird units like that because, like I said, it's the amount of energy required to change the temperature of 1 gram 1 degree. Okay, so the equation that we use for this is heat, which is Q, all right, Q is the symbol for heat, I don't know why, equals M, which is mass, times the specific heat. For simplicity for you guys, I've left specific heat as SH. It's often capital C also, so you could see it that way as well. Not in this class, but in the future. And then delta means a change in temperature. So delta T is the temperature change, all right? And delta T is always calculated as the final temperature minus the initial temperature. So if the temperature goes up, then delta T is positive. If the temperature goes down, then delta T will be negative. Okay, so in our problem, we're trying to find Q. Our mass is 225 grams, all right? Our specific heat is the 4.184, and our change in temperature is 22.4 minus 74.6. So we'll get a negative delta T here because our T is cooling, right? So then you really just do the math, plug it into your calculator, and you get an energy of negative 49,141 joules, all right? And we often report heat as kilojoules, which is 1,000 joules. So all you do is move the decimal over 3 places. So that would also be equivalent to negative 49.1 kilojoules of heat. All right. The other thing I just want to mention, we aren't going to have a whole lot of time to talk about delta H of fusion and vaporization. In the next video, I will talk about what delta H means, what enthalpy means, okay? But the specific heat values that I just talked about are relevant when we're changing the temperature. So a solid has a different specific heat than a liquid, which has a different specific heat than a gas. So even though it might be, water all the way across, the specific heat in each case is going to be different. And when we're adding heat, we can change the temperature when the phase stays the same, but then when we're undergoing a phase transition, like going from liquid to a solid, the temperature stays constant because all of that heat is going into breaking those interactions between the solid molecules to turn them into a liquid. And the same thing here when we get to going from a liquid to a gas, all of the energy is going into that, and so the temperature will stay constant.